Hello everyone, and welcome to this session about one API to rule them all. It's going to be a Lord of the Ring theme today. I hope you will get the jokes, or maybe not. So imagine if you could have one way of accessing your data, one API that could rule them all, one way of accessing, consuming, and supporting multiple use cases, like time series use cases, search use cases, analytical use cases, with one unified API, one API to rule them all. Well, today I'm going to tell you how that can be possible with using MongoDB Atlas. But before we start, I would like to set the stage where we are coming from to understand the background and the history of the data volumes that has been increasing over year. So the world has changed. Today, the world looks very different from what it did in the 70s, when the relational database was invented. And the relational database was invented to be able to store data most efficiently, because the cost of storage was really immense at that time. Yeah. But there are other things that has changed, but still we are using relational database technologies to be able to store data today. And this technology is from the 70s. Using relational databases today is really complex. And today developers need to be really efficient in the way they're building their applications, and using relational databases makes it really hard. For example, if you want to do a change in a relational database, you need to do schema migration, and it's not that intuitive to understand a relational database schema. Looking at this, you cannot get a really good understanding of what we are looking at. It's a lot of spaghetti here, yeah. And the database was invented in the 70s, but still we are using that technology, but it cannot support some of the use cases. And this is why there are other technology stacks that has been invented. For example, NoSQL databases, search databases, graph databases, analytical databases, and much more, and time series databases. So we are adding new capabilities by inventing purpose-built databases to be able to close the gap that we're seeing in relational database technology. By adding each of these new technologies, we're also adding new APIs, yes, new ways of interacting with the data and consuming the data, which makes it really hard. So there's not one way of accessing and consuming the data. So that means it's really hard to work with data. It's one of the hardest things you can do, working with data. And we have already hard things to do when we work as a developer. And as I mentioned in the beginning, developers is a scarce resource. So we need to be as efficient as possible. Also thinking about, when requirements change, we need to be flexible and to be able to adapt when the business requirements changes. And data is the foundation of our application. If it's really hard to work with data, then it makes it hard to actually deliver with agility and speed. Yeah. So I would ask the audience here, if you think it's really hard to work with data. If you agree, just raise your hand. Yeah. So I can see some of you agree. It's interesting. So how can we, why is that? Why is it so hard to work with data? As I mentioned, there are multiple use cases we need to support. So building modern applications today requires multiple technology stacks and multiple capabilities that we need to support. One of them is that we need to be highly responsive, to be able to have low latency, scalable performance solutions. Yeah, and relational databases cannot support that if you have big data or big scale amounts, big volumes of data. The other thing is that we need to be able to do search on the data, full text search on your data sets. This is something that's most common in most applications today. The other thing is to be able to deliver application to the mobile platform, and also to be able to secure your data and be able to be compliant, for example, with GDPR or any other regulatory compliance rules that are out there. And also be able to get insights over your data, running analytics on your data without moving the data. Also be able to when requirements change, to be able to adapt and implement those requirements without a large scale migration. So let's look at how usually organizations do to be able to support all of these capabilities that I just mentioned. So maybe you will start out with a relational database, and then you realize, well, I have the need to be a more flexible data structure. What you do then, maybe you add a document database, a NoSQL database, where you want to actually support that. But then you realize that it's not fast enough. So you need to have a cache. So what you do, you maybe add a Redis cache to have a fast read, low read latency, but be able also to read the data really fast. And then you realize, well, I need to have one more purpose-built data. Maybe I need to have a wide column storage. Yeah. Then you add that, and then you copy that data to that wide column, and then you continue adding more and more purpose-built databases. Yeah. You have the graph database for graph use cases, time series for time series, and then you continue maybe adding a search. You need to have full text search. You have a search engine like OpenSearch or Elasticsearch. And then you also stream that data to an analytics platform to be able to do analytics on your data. And on top of that, you have also, your mobile database. So all in all, you're adding more and more components, and you're copying the data, doing ETL between these different purpose-built databases, which means also all of these databases have different APIs, different ways of actually accessing the data, which means that you as a developer need to learn multiple APIs and multiple ways of consuming this data. And also sometimes, add maybe a layer that glues this data together, which makes it really cumbersome and complex to work with. And I haven't even mentioned, managing this, provisioning this, the security and everything around it. Yeah. So here we can see I have multiple APIs, multiple way of accessing, consuming data to be able to support multiple use cases, which makes it really complex for you as a developer. So imagine if you could have one API that could rule them all. How would that look like? Well, MongoDB actually is trying to solve that. So before I started explaining how that can happen, is that everything is based on the document model. So MongoDB stores that data as document, which is JSON documents, yes? And this means that it's really intuitive for you as a developer. Most developers today work with JSON. When they do REST endpoints and REST calls, it's actually JSON they're using, yeah? This is the typical protocol for data transportation today in web application and on the web. This means that we can use the document model to store and support multiple use cases. For example, our document model supports key value pairs, graph database capabilities, relationships, geospatial, time spheres, and objects, all in all with one unified API, which we call the MongoDB query language. So one API that could rule them all. And on top of that, with MongoDB Atlas, we have the capability of doing search, full text search capability, similar to OpenSearch and Elasticsearch. We have analytical capability with our aggregation framework. And we are also a distributed core. We are built as a distributed database. Yeah. We also support mobile application and serverless application. We have fully managed and available in all of the cloud providers. So with MongoDB Atlas, you can actually have one API that can rule them all. So before we start actually building the application that I'm going to, let's talk a little bit about myself. My name is Pierre Petersson. I'm an advisory solutions architect here at MongoDB. I've been working in the field more than 20 years. I like to do public speaking, and I actually came from Amazon before AWS, before I started at MongoDB. On the left, you can see me traveling with my family. I love to travel, but I don't want to pay for first-class tickets. So what I do, I collect air mileage points. So that's another, interest I have, except of, my work. So if you're keen on learning how you can actually go on first-class trips without paying for it, you can actually hit me up on LinkedIn, or of course, if you want to talk about the session I'm talking about today. So I'm happy to be here in Finland. So let's going to actually show the demo and show how we're going to build out the game. So we're going to build the Lord of the Rings games. So one API that can rule them all with MongoDB Atlas. So what does that mean? Well, I want to build a game where actually I want to be able to search for a character that I'm going to use in the gameplay. So a search field where I can actually search up for any of the characters in the Game of the Ring story. Lord of the Rings story. And then I want to be able, once I've searched and got the search list of characters, I want to select one of those characters. I want to input an email address. And then once I've input the email address, I want to actually see a map, a world map, where it's possible for me to click on that map. And when I click on that map, I store the longitude and latitude of that data in a time series collection, to be able to aggregate that information and plot that data to understand get the heat map of who has selected what part of the world. Yeah, and once I hit the right position on the map, what will happen is that the game will then reload, and so the movie, the Lord of the Rings movie, which shows that you actually have found the game. And everything is done using MongoDB Atlas, and I will have to also use a REST endpoint to be able to communicate. So search field, a microservice that can actually connect to the database, storing the data, a time series database, and I also need to do graph lookups. Yeah, so I need to be able to select an area in the world that I think the location is, and then query the database to understand if the user has actually selected the right area where the ring is located. I will talk about this when we come into the nitty-gritty details. So just a summary of the functionality that is required. Full text search to be able to look up the characters, Lord of the Ring characters. I need to have an access, some way to access the data using a REST endpoint. And that REST endpoint, I don't want to build it myself. I want to have it like a configured way of accessing the data without building on my own microservice. I need to store the data, and I want to store it in JSON because I have a JSON document describing all of these characters in for the Lord of the Ring. I also want to have time series support to be able to store the data with a timestamp and to be able to do different types of aggregations. Then also the gameplay would be a map where I can show a geomap where I can plot the longitude and latitude. And also, if we have time, I will also show you the archiving functionality to be able to archive the data. So in the land of Shaya, you don't want to lose any data in the case of Sauron comes back and want to look at the data. So with archiving, we can actually move the data to a cold storage, but still make it accessible whenever we want it, or join it with data that's live. So let's look at how we this build out if we do it not using MongoDB Atlas, if we do it using an AWS service. Well, we could use a React frontend to build a UI, but then we also need to have a REST endpoint, which could be the Amazon API gateway that will then in turn invoke Amazon Lambda function that will then query the Amazon document DB, which is a JSON. We can store JSON data in. Yeah. But the next thing is then we have additional requirements. We need to have search, yes. What would you need to do then? Then we actually need to have a search cluster also deployed and provisioned. And that data will need to actually move data from the document DB to the Amazon search data. So we're copying data. Yeah. And then again, we need to do archiving. We need to have an S3 bucket to do that, yes. And we need to move that data to that place also. Then also time series data, we need to move that data to the time stream. So we're copying data to all of these services. And then finally, the geolocation. Again, we need to copy that data to the geolocation service. All in all, we need to use different APIs to be able to support all of these use cases in the application. And as you can see, pretty soon it gets really complex. Yeah, I just have a search field, select a character, and then also a map to visualize the data. Even then, you have 7-8 services here that we have actually used to be able to implement this solution. And you can imagine how complex it will get when you get more and more use cases you need to implement. And on top of that, we need to visualize the data using a geomap. And then we need to use an external framework like D3 or similar to do that. Yeah. So this makes it really complex, even if you use managed services that are available in AWS. Yeah. So what about if we could do this with MongoDB Atlas? How would that look? Well, you have your mobile application. The mobile application will connect to MongoDB Atlas cluster using the Atlas Data API, which is our way of actually publishing your data through a REST endpoint. So the data that's available in your Atlas cluster. And what does that mean? Well, that means that you can actually configure a REST endpoint and get access to your data. You don't have to build your microservice. MongoDB Atlas also then supports all of the capabilities that we just mentioned. We don't need to have separate services for each of them that we did in AWS. So MongoDB Atlas, you keep the data in one place, and we have support for full text, or we have full text search with Atlas Search, which is based on Lucene. We have native JSON support. We have time series support. We have geolocation, where we can do lookup on geolocation, store the data, longitude, latitude. We have archiving support, and of course, visualization to be able to show a world map where we can click on, Atlas charts. And we have serverless function and much, much more. But the focus for today are these requirements I'm listing here. And then on top of that, of course, we need to have a front-end, React front-end, a static front-end that we will host in S3. No, sorry, we could host it in S3, but MongoDB Atlas also has a hosting service embedded. So we can use MongoDB app services to actually host the application also. So with that said, let's try to look at the demo. So demo consists of actually, so what we'll do in the first step is actually to search for something, search for a character. So here I'm searching for Frodo. So what will happen in the background is that then it will invoke a REST endpoint, which is our MongoDB Atlas data API. And that will then invoke and query the database using full text search, which is embedded. We are not provisioning any extra things. Everything is in one place. Yeah, we keep the data in MongoDB Atlas and just create a search index on top of that. This means that we can use the same MongoDB query language that we do to be able to query the database. Yeah, so the database and the full text search index are combined, so we can actually query both using the same standard MQL MongoDB query language. Once we have returned the result from the full text search, that will be then returned to the UI, the React application, which will do the listing of that. So let's look at that. So I will show you how I create the search index. So here I'm logged into my Atlas cluster, and you can see I have a demo cluster here. If I click on the demo cluster, I can see that I have a search tab here, and I can create an index. So here I can select I want to use the visual editor or JSON editor. For now, I will just use the visual editor, and I will name the index Lord of the Rings 5 maybe, and I will I will have Lord of the Ring, and also the collection I want to, this is the table, we call it a collection in MongoDB, which I want to have a search index. So let's look at that data. So this is the characters, as you can see. So I'm creating a search index on top of that. I'm not provisioning, again, any extra things. I'm just creating a search index. And I'm telling it that I want to use the characters collection. So now I have some additional configuration. For now, I will just keep it as is. You can also refine your index, just have specific fields that you need to have indexed. But for now, I'm using a dynamic mapping. And then I create a search index here. And a couple of minutes later, you will have a search index already created. As you can see, I've created a number of them. Here I have the lotter index here, which I will use. And I can then use that to be able to do search query. Great. So now we have actually created the search index. Yeah. The next thing is to actually create the REST service endpoint. This is the endpoint to be able to do REST calls to the database. Yeah. So there are two ways of doing it. One way is using the data API, which is our global wrapper. And then you will have an endpoint where you can actually, this endpoint you can use, and you can also understand how you need to access that data. And you can also set granular access controls here to be able to see what that user can do. Currently, I'm using an API key. But for making it a bit more interesting, I have actually not used it. I'm using the data API, but I'm also customize it using custom HTTP endpoints to be able to also trigger some functions. With our app services stack, we can actually use serverless functions, but also a custom HTTP endpoints, GraphQL, and much more. So here I've created my application called Lord of the Ring. If I go here, I can see that I can then look at my custom endpoints, HTTP endpoints. I have two of them. One is search and one is hint. So for the search use case, I have defined the endpoint root search, and the linked function is do search. So once I hit this endpoint search, what will happen is it will trigger this function called do search. And the do search function, what it does is actually executing the MongoDB query. And this is exactly the same query that you will run in MQL. It's nothing different running this in Compass, which is our tooling for looking at the data. I can show it here. As you can see, it's the same query. And I'm putting the query here, running it the same way. So by doing that, I have now created both the search index, I have created the REST endpoint, and the next step is to actually store the application or the user credentials. So now we have searched for the character we want to play with, and then the next step is to also sign up or log in to the game by defining the inputting your email address. Yeah. And that will authenticate the user and log into the user. And we have different ways of authenticating, different IDPs we support. So once you're logged into the game, what you will see is a map, and this map is where actually the gameplay starts. Yeah, and when you click on the map, every location, longitude, latitude, that will be stored in the time series collection with the longitude, latitude. We also have the capability to do geolocation lookups to be able to decide if you actually clicked in the right area where the ring should be. And we can also visualize this with the visualization map that I just mentioned. So with that, I would like to invite everyone to actually play the game, because this is a recorded session. I will show you the game. Let me show you the game. So I will go to Lord of the Rings. Let me make it a bit smaller. So let me search for Arwen. I will find the I think this is my gameplay character, and then I will select my email address, Pierre Petersson at mymail.com, and then play the game. So as you can see now, I have a map has been loaded, and I can then select to click on the map. So I can click here, and what happens now in the background is that it's storing that location in the time series database. Yes. So if we look at the time series database here, I have the hints time series database. We can see now I have 113 documents. So if I click one more, I should have 114 documents. Yes. Yeah, 114. So it's storing the location, the longitude and latitude, as you can see. Yeah. And once I have found the ring, it will then show me a movie that the game is ended, game over, or you have completed the game. I can click anywhere here, you can see. And I also have different other types of graph I can show. So I can also show like a dashboard of heat maps and stuff. So here I can see where is the most common place users have been clicking. It seems to be in this area. I can zoom in, zoom out. And there are different charts also in MongoDB. This is just an example. We have bar charts, stacks, and everything. But easily, I have now created a game without much effort. Yeah, because everything I use, everything is in one place. I can use one API that can rule them all. But let's find a ring now. Yeah, I found the ring. Yeah, the game. Just some background. I've never worked with React. This was my first React application. I'm a Java guy from the beginning, and I managed to create this demo in 2 days, with my normal work. But it was really fun, and I would really recommend you. If you want to try this out yourself, there is a GitHub repository where you can look at and try it out. And please let me know if there's something missing in the documentation. So here's the GitHub repo. I created this just for this event. And if you want to look at it, please have a look and try it out. I hope this was interesting.